All right, ladies and gentlemen, here you are in your very first video where today we're talking about bonding rule number 1. So, rule number 1. In case anyone has forgotten, rule number 1 is that all atoms want a full valence shell. Now, there are two words we need to talk about in this rule. First is valence. Valence means outside. So we can talk about a valence shell, which is the outside shell, or we can talk about valence electrons, which are the electrons that live on the valence or the outside shell. The second word we need to talk about is want. Atoms don't actually want anything because they're not people, they're not alive. So when I say an atom wants something, an atom, because of the second law of thermodynamics, is always going to go to the most energetically stable state. So atoms are most stable when they have a full shell. So we can say all atoms want a full valence shell, and we know that atoms with full outside shells are the most stable. So there are two ways to do this: to gain or lose electrons, and then to share electrons. Now, if we gain or lose electrons, this bond is called ionic. And this is a nice vocabulary word because if we look at this root, this ion part, ion means a charged atom. And so when we gain or lose electrons, we're going to an ion, and then ions make ionic bonds. Or we can share electrons and make covalent bonds. And when we look at this word, this co part means sharing or together, and valent is like valence, like we're talking about sharing valence electrons. So we've got ionic bonds if we gain or lose electrons, and we've got covalent bonds if we share electrons. So the question now becomes to steal or to share your electrons. So when we're talking about stealing electrons, we're talking about making ions and ionic bonds. And so those atoms are almost always from columns 1, 2, 16, and 17. So columns 1 and 2, we're talking about things like lithium and sodium and beryllium and magnesium. And in 16 and 17, that's where we've got oxygen and sulfur and fluorine and chlorine. So these guys will almost always lose or gain electrons to become ions, and ions form ionic bonds. You can also check the ion list if you want to be double sure that your element is going to become an ion. And the ion list is also really handy because we can check for molecules like hydroxide, which has a -1 charge. And so that ion list is really good for not only telling you if you're going to get an ion, but what charge it's going to have. However, there are some atoms that play nice and they don't steal electrons, they share their electrons. And these atoms live in columns 13, 14, and 15. Particularly out of column 14, carbon is the friendliest atom you will ever meet and always, always shares its electrons to form covalent bonds. All right, so let's talk about making these ionic bonds, which is the first way to fulfill rule number 1, gaining or losing electrons. Now, this slide is your cheat sheet for how to figure out ionic bonds. So if you ever get stuck with an ionic bond, come back here. Step number 1, in order to gain or lose an electrons. First, you got to find the element on the periodic table. So if we're looking for sulfur, you got to find that S is number 16. You got to find it on the periodic table. Step number 2, how many electrons does that element have in its valence shell? Remember that valence means outside. Okay, so if you don't remember how to find that, you're going to have to draw the full Bohr model, which is the circles, and put all the electrons in where they're supposed to go and figure out how many are in that outside shell. Step 3, what is the easiest way to get to a full valence shell? Atoms are never going to go for +6 or -6. They're always going to go for small charges. So is it easier to kick 1 or 2 electrons out, or is it easier to steal 1 or 2 electrons from someone else? And then the very last thing you do, once you figure out if you're adding electrons or taking them away, is figure out what charge that makes the atom. Okay, so that was a lot of steps all at once. So I'm going to give you an example walking through those steps. So let's take the atom beryllium for an example. So here we have our beryllium. Okay. Beryllium is atomic number 4, which means it has 4 electrons. And if I'm going to draw the whole Bohr model with the circles, I need 2 circles. Now, the first circle can only hold 2 electrons. So, electron number 1, electron number 2, and then I'm going to end up with 2 electrons in this outside shell. So this is what beryllium looks like. Make that one a little bit bigger. Okay. Now, we know that we now have 2 electrons in the valence shell. All right, so that was step 1. We found the atom, and step 2, we figured out how many electrons it had in its valence shell. Step 3 is to say, is it easier to lose electrons or gain electrons? And for beryllium, it's going to be much easier to take these electrons and kick them out than it is to be able to find 6 electrons from somewhere. And step 4 is to figure out the charge. Now, you have to remember that electrons are negative. So if we're kicking electrons out, we're losing electrons, we're losing things that are negative. So we're going to end up with a +2 charge on this atom. Okay? Fluorine, on the other hand, fluorine is atomic number 9. So when I draw its electrons, I'm going to have 2 circles, 2 electrons in the middle, and then 1, 2, 3, 4, 5, 6, 7 electrons on the outside ring. Okay? So for fluorine, it's going to be much easier to take and add an electron than it would be to kick out 7 electrons, because fluorine had 7 valence electrons. This E minus here, that means electrons, because electrons are negative. Okay, so when we add an electron, we're adding something that's negative, so we're going to end up with a -1 charge for fluorine. All right, so we talked about ions and how to make ions, but atoms can also share their electrons. So for this, it's important to remember rule number 3, which is that only valence electrons matter. And if you are a little bit confused about that, or you need to remember how to draw a Lewis structure, go check out the rule number 3 video and then jump back over here. So, first step, this is always the first step, find all of the elements on the periodic table. Okay, and then again, you need to know how many electrons do they have in their valence shells, on the outside shells. Now, rather than stealing them or donating them, we're just going to rearrange those atoms so that everyone feels like they have a full shell. So, let's go look at an example. So for this example, I'm going to talk about carbon, because carbon is the atom that is most likely of any of them to make a covalent bond. And carbon has 4 valence electrons. I know this by looking at where it is in the periodic table or by drawing the Bohr model, which I'm not going to do here. Now, carbon will often share electrons with hydrogen, and hydrogen has 1 electron. And so we'll bring 4 hydrogens to this carbon atom, and each one is going to start sharing its electrons. And so you can see hydrogen's electrons are blue and carbon's electrons are black. Now, when we look at this, we count 1, 2, 3, 4, 5, 6, 7, 8 electrons that carbon can see here. So carbon's like, sweet, I got a full shell. Now for this hydrogen right here, it sees 1, 2 electrons, which makes a full shell for hydrogen, because we're only talking about that first one that holds 2. And that's true for all of the hydrogens. They can see 2 atoms. So now all of the hydrogens are happy and all of the carbons are happy. This is another example of a covalent bond. We're talking about phosphorus and chlorine here. And so you can see that chlorine has red electrons, and it's got 7 of them. So 7 here, 7 there, 7 on this one. And phosphorus has 5 valence electrons, and they're black. So 1, 2, 3, 4, 5. When we put all of these together, we can see that chlorine still has all 7, but it's going to sneak up in here with phosphorus. And because you can see there's kind of an empty spot here for an electron, and there's an empty spot here. So these two are going to snuggle and form this bond. And the same thing's going to happen over here. We can see the empty spot and the empty spot. And the same thing's going to happen down here with this one. We have this empty spot and this empty spot, so they're just going to sneak right up in there like that. And so now we have 3 bonds with phosphorus. We have this bond as a covalent bond, this is a covalent bond, and this is a covalent bond. And we can see that all of the atoms feel like they have 8 electrons because they're all sharing. So that was your summary of rule number 1. We could either go ionic or we could go covalent. And thanks for watching.